questions 4M1 and 4M2 for Statistical Rethinking, fourth chapter. Okay, so our first one here is for the model definition below, simulate observed y values from the prior, not posterior distribution. And so here's the model, and this is just priors. Right, so we have a prior for the observed data. We're saying that it's normally distributed with a mean mu and standard deviation sigma. And our prior distribution for mu is that it's normally distributed with a mean 0, standard deviation of 10, and that sigma is distributed as an exponential distribution with a rate. It's called a rate or a lambda of 1. Okay. So what we're doing here is we're creating what's called a prior predictive distribution. In the past, we've seen posterior predictive distributions, but this is just telling us what does our prior in the model expect to happen. What kind of data is the prior expecting to see? Okay, and so an easy way to do this is just to begin simulating line for line. But we have to, okay, so we can start with y, or we might want to start with y, but we can't because it's defined in terms of mu and sigma. So first we have to define mu and sigma. So here we have a mu prior, okay, and it says that mu is distributed as a normal distribution with a mean 0 and a standard deviation of 10. So we're using the R norm function in R, and we're going to simulate. We're going to make 10,000 samples with a mean 0 and a standard deviation 10. Similarly, for the sigma, we have an exponential distribution with a rate of 1. Okay. So we have our sigma prior. We're going to simulate 10,000 samples with a rate of 1, and that's just how we define an exponential distribution. Okay. And now that we have our two parameters set up, we can simulate prior data. Okay. So y is distributed normal with a mean mu and standard deviation sigma. So we use again our norm, 10,000 samples with a mean mu prior and standard deviation of sigma prior, which we've defined above. And so what this is going to do is it's going to take the first sample that we generated from our norm, and then the first sample that we generated from sigma, and it's going to put those together, and it's going to create a norm. It's going to randomly sample from that. Okay, and so then I'm going to display y prior here. Okay, and I'm going to display in a DINS graph and then a histogram. Right? So this is what our prior distribution looks like, right? For y, again, it looks normalish in shape with a mean mu, and here mu had a mean of 0, so we see that at 0. That's pretty easy to deduce from the model. The width here, the variation, the spread of the distribution is a little bit harder to intuit because it's based not only on standard deviation for sigma, but also the spread of mu. And so anyway, that's all captured here in the prior predictive distribution. Okay. Question 4.2 is to translate the model just above into a quap formula. Okay. So we're going to translate this into the notation that's used by the Rethinking software in R here. Okay. And so some of this is just dressing because this is how our models will look eventually. Okay. But this, well, really, this is the important parts here. Okay. We have that y is distributed again normally with a mean mu, standard deviation sigma, and then we've defined those priors here. Okay. And so this is how, in the Rethinking package anyway, not in all packages, but this is how we begin to translate our kind of written statistical model into a coded statistical model. Okay. You'll notice that this does not run because this is not a complete command. We'll see how to do that later, but we're missing what data we're supposed to be using here. But anyway, that's it for this one.